Hi folks, this is Mitas Dodes. I'm the lead developer of MITE, the minimum information about the tailoring enzyme, data standard, and repository. Today, I'm going to show you how to submit new entries. But before we do that, a little bit of background. So what is MITE about? MITE is both a data standard and a data repository about tailoring enzymes. Tailoring enzymes are special enzymes that modify certain products, so-called natural products, also known as specialized metabolites or secondary metabolites. Oftentimes, these metabolites have certain bioactivities, and sometimes these bioactivities only appear because the tailoring enzymes modify this core structure, give it additional properties. So MITE captures this reaction, but also the subspecificities of these tailoring enzymes, because these can vary widely. And it presents this information in both a human, but also a machine-readable form. And this is very interesting because we can use it then for example, for machine learning, for predictive purposes. So this is about the background. And let's talk about how to create new entries. Right. So the first step is, of course, finding a publication that describes a tailoring enzyme and its substrate specificity. This is important because MITE only describes experimental data, so no predictions. For this example today, I've prepared already a paper, which is this one here. It's a biuretide-linked tripeptide from planospora reveals a widespread class of minimal RIP gene clusters. This paper is about cytochrome P450s, and I chose this paper because I'm the first author and I know everything about this enzyme, or at least I know a lot. So it's a cytochrome P450, and what it's about is that it's modifying a tripeptide, BYTA, and it's introducing this interesting BRL bond between the first tyrosine and the histidine here. So what we have to do first, before we start describing this enzyme, is to go to the repository page of MITE and check if somebody else has already described BYTO. So as you see, there's nothing about BYTO, BRL. Yes, there is a couple of BRL introducing enzymes, but none of them is BYTO. So we can continue here. So first we have to go to submit an entry. And here's also another check that we can perform. There's this pending submissions. They are not in the repository yet, but maybe somebody else has already described BYTO in these pending submissions. So it's best to also go there and check, so to not to have duplicate work. But in this case, nobody has described this before, so we can go and submit BYTO as a new entry. So first of all, we have to fill in a little bit of enzyme information. So the enzyme name, this would be BYTO. The enzyme description, it's a cytochrome P450. And then here we have to fill in some database crosslinks. So one of them is the UniProt KB or UniPark ID. And this is easy to find. You just have to go to UniProt, and usually we can find the enzyme, the UniProt ID, by just using this generic name, BYTO. Okay. So this results in 2 entries, and this is okay because we have actually described 2 very similar cytochrome P450s, but from different strains. So we have to first find the right strain. In this case, the strain information is here. So this is the second strain, the one that I don't want to talk about, and therefore this must be the right strain. Yes, 82291. So here we just go and take the UniProt ID, copy pasting it here, copied it, paste it in here. Then it's very nice to also fill the NCBI GenePept ID if it is known. Sometimes it is also here available on UniProt, so we can give it a try, NCBI. But unfortunately, here we only have the taxonomic identifier. But luckily, somebody has deposited this virus into the gene cluster already on MIBIC. Viralitide YYH, and it's this one here. So when we go to compounds, to genes, we click on this gene here. We have here the protein ID, the NCBI GenePept ID, and we can just take it from there. Note that you don't have to fill both of them, but you have to fill at least either the UniProt ID or the GenePept ID, one of the two. We can also take the MIBIC ID, which is here, 2084, also paste it in here. And then a reference DOI, a digital object identifier. So in this case, we can find it here. Just copy it, paste, and remove this first part. It must start with DOI, colon, 10, and something, something. Okay, so we can also add additional references if we need, but yeah, we have to provide, or we must provide at least one. Auxiliary enzymes, these can be added if necessary. These describe enzymes that to be in the vicinity or yeah, at least present, that this first tailoring enzyme can work without flaws. But in this case, we know that this cytochrome P450 works without any partner. Now about the reaction information. This is the most important part of the MITE entry, and it describes both the reaction, but also the substrate specificity, and how we, what we planned, or how we are going to capture this information is by drawing a reaction SMARTS. At this point, I have to tell you a little bit about reaction SMARTS. Reaction SMARTS are a molecule structure matching engine, like a search language, that also allows to introduce chemical transformations. In other words, you can draw reactions with that and present it in a computer readable fashion. So we are going to do that right away. First of all, I'm going to fill some more information. So what kind of tailoring is this now? This is a biaryl bond formation. Yeah, multiple terms can be clicked, but in this case, this is the most relevant one. And in terms of experimental evidence, yeah, since I am a co-author here, I know we did a heterologous expression and proved that using this technique. The reference can be, again, the same as before. And now we describe it. Introduction of biaryl bond between tyrosine and histidine. Okay, let's start drawing. For the drawing part, I recommend, or we can recommend using Catcher. It's a free open source tool that allows you to draw structures in your browser. So I already opened it here. And of course, we can now go and start drawing this. For example, searching for tyrosine, and L-tyrosine, and we can take it and click it, like edit here. But luckily for us, somebody else has drawn this structure before and deposited it on MIBIC. It's also in MP Atlas, and we can just copy the SMARTS here and paste it in here. So that will be our product, and we also want to have the substrate, right? So we are drawing, so we are just pasting it in here, and we will go and remove this bond here. And we also know that this acetylation is happening later. So we are also going to remove that one. Also here, we are going to remove, excuse me, disable this for 1 hour. So I'm just going to remove this part. So we have a substrate in our product. And first of all, we are going to take this molecule representation and export it as a SMARTS, so-called SMARTS string. So we can select this, and then we have to bring this into the so-called aromatic form, because currently this is in a kecular form. And what we want to have is the aromatic form. We just press here on aromatize, or I'll press Alt and A. And now you see the aromatic rings are now shown as with a circle in there, and that means this is aromatic, and also the computer understands that this is aromatic. We're going to do the same thing here. Yeah. So we have now our substrate, and we are going to save that. So you can also select here, save as, but easier it's just to press Control S. And we are going to take daylight SMARTS. I'm just double clicking on here, copying it by Control S, going over to my the MITE page, and paste this the substrate SMARTS in here. So first step, now I'm going to the product, selecting it again, saving it as a SMARTS, and pasting this into the known reaction. So the difference between the, let's say, general information reaction and the known reaction, or between reaction SMARTS and the SMARTS, is that the SMARTS depict the actual product, while the reaction SMARTS is more of an abstraction. That's basically the recipe. So if we take the substrate SMARTS and apply the reaction SMARTS to it, then the product SMARTS must come out of it. That's at least the idea. Okay, let's add a brief description. That's the diaryl type YH formation. Again, this describes the actual reaction. Okay, so now we are going to draw the reaction SMARTS. And for that, we are going to our product, and we are just going to copy this with Control and C. We are going to our substrate. We are adding a reaction arrow, just like that. And then we are going to paste the product in here. We are going to select everything and use a very nice tool, which is found in here, and it's called the Reaction Automatic tool. And what it does is it's giving each of these atoms that are on both sides an index. We're just using the discard mode. And as you see, all these, the atoms are numbered identically on both sides. So for example, this atom here, both have 24 and so on. And this is very important later on if we have, for example, substitutions, if we have if certain atoms are removed, for example, if this hydroxy group, this carboxyl group is leaving, then we would, or the computer would know which atoms are now gone. Well, this is basically it. We just have to select this whole reaction SMARTS, and again, say Control S. And then we select Daylight Smarts. Double click on this again. Go over to our page, paste it in here, and we are basically finished. So there's some more submit information necessary. We have our org ID field that I would very much recommend to use. This way, your submissions and your work can be credited appropriately. But there is also the possibility to leave this blank, and then you are submitting this entry as an anonymous submitter. So then here, there's the changelog. We are describing whatever we've done. In this case, we have created entry, so we can just say new entry. To protect our servers from malicious attacks, we have a little bit of a math challenge. Should be very easy to solve. And then there's also the terms of use. Please read them. It's basically saying that you are releasing your work to the public domain with appropriate referencing of and attribution. That's the right word. Yeah. And then it's basically finished the review. So we just click the submit data for review. And if everything worked out in terms of validation, you get a submission successful message. You also get the submission ID that you can reference later. And in a few, so we still have to briefly look at your data and so on. But then once this is done, your entry will be put under scrutiny here on our GitHub page. And as you see, there's already a couple of entries that are waiting for review. And you are also very much invited to join the discussion here. Everything is public and open if there is, for example, any issues to resolve. Okay, so that was smooth, I think. Now let's take a look at modifying an entry. So let's take a look at this entry here, for example. Very complex, but the details are not so important at the moment. Okay, there's a glycosyl group being attached. Let's go and modify this entry. I want to show you now what happens if you, if there is any errors in your submission, and because in the back end of our server, whenever you click on submit an entry, there's some complex validation going on, especially checking if the reaction SMARTS, when applied to the substrate SMARTS, is leading to the product SMARTS. That's the most important thing of the validation, because we also always want to make sure that your reaction works on the non-reaction, basically a sanity check. So what we can do, for example, is we can just start modifying this here, adding a couple of C atoms, and there's a couple of reactions. I think some of placeholder. I'm just going to fill the required fields, because what I want to show you now is following test. What happens if we make a mistake? So if we make a mistake, then the engine will run and it will say, hey, you did a mistake. There was an error during the automated validation, especially for the reaction. And it says the product, so and so, this is the product, does not meet the expectation. See, that's the one that we broke, basically. There's some additional information down there, but that's not so important. And there's help available on the troubleshooting page. And I can visualize what the problem here was. So I'm just going to copy this here and paste this into catcher, move. So this is expected, right? Oh, this was produced, but we said, oh, okay, we made a mistake, and we said this is what we expect. Yes, as you see, we introduced this long chain of C's, and that is not what is being produced by the reaction, right? So the validation was correct, and we made a mistake basically. And so having this validation in place is very important because this protects us from wrong submissions. Okay, so there's a couple of more, let's say, commonly occurring issues which can be found on the help page, right at the bottom, some troubleshooting. And if you want to have a step-by-step explanation, you can also take a look here at our examples. So I hope this was clear, and I am very happy that you're interested in submitting the data to MITE, and I'm looking forward to see your entries on our GitHub page. Goodbye.